Two-dimensional arrays. A two-dimensional array is useful for storing a matrix of information, like a 6x6 seating chart. Think of this like a spreadsheet with rows and columns. Just like with 1D arrays, all the elements must be the same type and initialized, otherwise the array is null. Here's the syntax for 2D arrays. Notice there are two sets of square brackets, and over here, this assigns the size of the array or the number of compartments. So this array has 2 rows and 3 columns, and you can visualize it like this. There are no limits to the number of dimensions arrays can have in Java. The real limit is the amount of memory available to the programmer. The number of cells is the product of all the dimensions. The size of each element depends on the data type of the array. For example, this is an array of type int, so each element is 4 bytes in size. Therefore, it has 2 times 3 times 5 times 20, which is 600 elements, each being 4 bytes, for a total of 2400 bytes. If we change array A to type double, each element will be 8 bytes in size. It would still have a total of 600 elements, but its total size will be 600 times 8 bytes, or 4800 bytes. The AP exam focuses on 2D arrays, so we will as well, but it's good to know that more sizes are legal. We can interpret a 2D array as an array of arrays. For example, if a one-dimensional array is visualized as a series of compartments in a row, then a 2D array is a series of 1D arrays. For example, we have our array A here that has 2 and 3, so it has 2 rows. Each one has 3 elements, and each element will be of type int. Each subarray's length can be used to find a specific element in that row, provided that this is our array with 3 and 4, then x.length provides the number of rows. So here is x.length, and that's 3 rows. To find the number of elements in each row, we must specify which row we want by using x, then the row number dot length. So the length, x0.length, is 4. There are 4 compartments. And that's the same for the second row and the third row. A unique feature in Java is that 2D arrays do not need to be uniform in size. If each row can be a different length, this is referred to as a ragged array. For example, here we have a 2x3 array, and by saying A1 equals new int 4, we've changed row 1 to have 4 elements. All arrays can be initialized with values the same way, so 2D arrays are no different. We can initialize by using curly braces and listing values, individually by specifying the element location and assigning a value to it, or using a loop to fill the elements. Let's take a look at how to fill the array num23 with the numbers 1 through 6 using the 3 different methods. Each way has the same exact outcome. Here we can use curly braces and list values. Notice the double curly braces that surround all of the listed elements along with the curly braces that initialize each subarray. So here we have our first subarray, then a comma, then our second subarray. Here we are just going in and accessing each element individually and assigning values. So this will be the first row, first column, first row, second column, first row, third column, and so on. The most efficient way to fill the elements of an array will always be with a loop. In order to walk through the first dimension, use a for loop. Each element is no longer a single value. To process the second dimension, remember that the result of the first loop is an array. In the example below, a row is an array and therefore has a length. It is common to use nested loops when traversing a 2D array. Also, notice the use of the identifiers row and col instead of our typical ing. This is helpful when trying to keep dimensions and calculations straight. Let's practice. Let's fill a 2D array so it looks like this. Let's walk through this line by line together. We start out by creating a 2D array A that has 2 rows and 3 columns. Then we declare a counter variable int x, which will help us fill the cells with the correct numbers. We're going to set it equal to 1 since we're starting with 1. The highlighted for loop here will loop us through the rows of the array. When we begin the loop, we're at row 0, so this row here. Before we move on to row 1, we have to enter the second for loop. Now we're inside the second for loop, which loops through all of the columns. When we first enter the loop, we're at row 0, column 0, the top left box of the 2D array. We set the value equal to x, which is currently 1, which we declared on the second line in the code. Finally, we increment x by 1, so that when the nested for loop starts again, we set the next box, top middle, equal to 2. Once all of the columns of row 0 are filled with 1, 2, 3, the nested for loop ends, and we return to the first for loop. Now we start the loop for the second row, right there. We loop through all 3 columns, 4, 5, 6, and then both loops end. To print the array to the terminal window so that it looks like this, we use most of the same code. However, we replace the code in the middle with a print statement that prints the contents of the box we're currently accessing. Also, we included a print statement after the nested loop that inserts a new line. That will make sure every row shows up on its own line.